Okay, hello Year 12. This is just a little video to help you with your gas calculations. Sorry about the shadow being cast across the screen. You're just going to have to put up with it. You are currently being recorded on my phone. It's in a shoebox, balanced on 2 yoga blocks. I'll show you. It's a very cool setup. I think you'll agree. There we go. That's what we're dealing with. So you've got a shadow today, and it's just going to be, that's the way it is. So get over it. Right, I hope you've had a good first day of lockdown. Hope none of you are too poorly, and you're keeping yourself safe and your family safe. So I've been asked to go through some of these gas calculations. I want to keep it brief. PV equals nRT. It's called the ideal gas equation. Yeah, I need to read this bit at the top. An ideal gas is a gas that has no forces between particles. Now, real gases aren't actually ideal gases, but this equation here is really, really good and really, really useful to be able to calculate things like number of moles if you've got the pressure and the volume and the temperature of a gas. So you'll recognise these questions straight away in an exam because they'll give you pressures, volumes, whatever. They'll give you 1, 2, 3, 4 out of the 5 required terms, and you just need to be able to rearrange this. So first thing I would suggest that you do is make sure that you can rearrange this equation. So if you have PV equals nRT, that's the pressure of the gas times the volume of the gas, will tell you the number of moles of gas that you've got, times the gas constant, which is 8.31, times the temperature. Let's just see if that's going to focus properly. Yeah, it's a bit blurry, isn't it? It's not ideal. Right. Hang on, maybe if I touch this and then it'll focus it and keep it focused, maybe. So sorry if it keeps going in and out of focus, but that's just the way it is. The key about these, and you might have got that from my message, they are all about the units. So if you're rearranging this, it doesn't matter how well you can rearrange it. If you don't know the units, you're never going to get the right answer. So if PV equals nRT, if I wanted to work out, if somebody asked me work out the number of moles, that would be, I need N as the subject. So if PV equals nRT, to get N as the subject, I need to get rid of the RT. So this is N times R times T. So to get rid of the R and T, I need to divide both sides by the RT. So I'll do that. N equals PV over RT. You need to be able to do that conversion very easily. If you've got PV equals nRT and they ask you to work out the volume, you would divide both sides by P and you'd have it like that. So you need to be able to practice that. They are not hard rearrangements because everything is times by one another. You have to be able to convert between decimeters cubed and meters cubed, centimeters cubed and meters cubed. Because you'll notice here that the volume is always in meters cubed because this is a physics equation and that's an SI unit, a standard unit. So a decimeter cubed is effectively a litre. You just need to know to turn that into meters cubed, you need to divide it by 1,000. So 1 decimeter cubed is 1,000 times smaller than a meter cubed. So to turn decimeters cubed into meters cubed is 1,000. To turn centimeters cubed into meters cubed, you have to divide by 1,000,000. So decimeters cubed, you divide by 10 to the 3. And centimeters cubed to meters cubed, you divide by 10 to the 6, 1,000,000. 10 to the 3, 10 to the 6. So if you have 1 centimeter cube, you have 1,000,000th of a meter cubed. I hope that makes sense. So 1 little centimeter cubed of that. If you've got a meter cubed, you've got 1,000,000 of them in a meter cubed. Pressure is always in pascals, and they'll pretty typically give it you in kilopascals to make life difficult. So a kilopascal is 1,000 pascals. So if you've got 2 kilopascals, you have 2,000 pascals. Hope that's all right. A megapascal, you can see here, that's again times 10 to the 3, and megapascal is times 10 to the 6. So you're getting used to kilo and mega. So if you've got 2 megapascals, you've got 2 times 10 to the 6 pascals. So remember, just do this, 2 times 10 to the 3. All right, the final thing there to watch out for is temperature. The examiner will give it you in degrees C because they want you to do the conversion. Degrees centigrade to Kelvin. Now, I'm not going to go deep into what Kelvin is here. I hope you've come across it at GCSE. In fact, I should know whether you've come across it at GCSE, and I'm pretty sure you have. Anyway, to turn degrees C into degrees Kelvin, you need to add 273, so don't fall for that. Now, So on each of these questions, what I recommend you do is you just go around and you collect terms. You collect what information you've got. I'm not going to do the top question because you can do that. I'm going to look at question 2. So it says here, question 2, just going to check that you're in frame there. Question 2, calculate the volume. So we've got P, I'm looking at this, I've got a volume, I've got moles, I've got a temperature, and I've got a pressure. So I would go P, V, N, R, T. R is always 8.31. It's asking me to work out the volume. It's giving me moles, that's N, so that's 0.4 moles. It's giving me 100 degrees C. Oh, I'm not falling for that trick, so I'm going to write 100 degrees C. I'm going to do the unit check in a minute. And a pressure of 1,000 kilopascals. Haha, so this is all about the units. So you see PVNRT and you think units. Okay, units, kilopascals, I've got to change that. So that's 1,000 kilopascals is 1,000 times 10 to the 3 pascals. N is 0.4 moles, I'm happy with that. 8.31 joules per mole per Kelvin, I'm happy with that. 100 degrees C, you add 273 to turn it into Kelvin, so that's 373 Kelvin. Now you are good to go. So they want me to work out V. So you go PV equals nRT. To work out V, V equals nRT divided by P. You plug those numbers in, you get the answer. I'm not doing that for you, your answers are in the back. Okay. How many moles of gas occupy? So that's asking, question 3 is asking you for N. And look, they're giving you a volume, units, they're giving you a temperature, units, they're giving you 1 atmosphere here. Ooh, are they telling you what that is? 1 atmosphere. 1 atmosphere pressure. Now, are they giving you that there? I don't think they are. You know what you're going to have to do there? Because I am at home and I'm about to put the kids to bed, you're going to have to Google what 1 atmosphere pressure is, because you need it in pascals. Unless I'm missing something and it tells you that somewhere. You're going to need it in pascals. So remember, the question is all about units. In an exam, they would tell you what that was. I think it's 101 kilopascals or something like that, but you can't take my word for it. You've just got to go and look that up yourself. Okay, question 4. So you're going to have to rearrange for N on question 3. Question 4, calculate the pressure. You're going to have to rearrange for P. And that means you must be given V, N, R, and T. V, N, T, and R is 8.31. So these are pretty steady. I've been asked by someone in the class to go through the more difficult questions towards the end of the paper. In other words, when they start to integrate the skills from other parts of the course or other calculations that we've done. So question 7 here, for example, you've got an equation. So I'm going to write the equation out. CaC2 solid plus 2H2O liquid makes Ca calcium hydroxide, CaOH2 aqueous plus C2H2 gas. Not that these... Well, actually, the state symbols are important because we're making a gas. This is the gas bit of the equation. So what does it tell me? What mass of potassium chlorate... No, wrong one. Find the volume of ethyne. So it wants a volume of this. And I'm imagining it wants it in meters cubed, but I'll have to do it, I'll look at the answer in the back. I can convert between them, so I'm not that bothered. Find the volume of ethyne that can be prepared from 10 grams of calcium carbide. So you don't panic in these. You think, well, what can I do? Well, they're giving me 10 grams of this, 10.0. That's 3 sig figs, by the way. At 20 degrees C, oh, you cheeky monkey. Right, that is it's looking like they're doing the units thing. So this looks like a PVNRT. So they're giving me 20 degrees C. I'm not falling for that. They give me 100 kilopascals. I'm not falling for that. Where am I? Keep losing my place. 3 sig figs. They're giving me, well, R will be 8.31. They're asking me for V, but I haven't got N either. Oh, right. So I need to work out the N and then I can work out the V. Anyway, let's have a little look what's going on. They've given me 10 grams of calcium CaC2. Well, you think, well, what do you do? And I've said to you in the class, make sure if you're going to cheat in the exam, make sure you get that tattoo. Turn grams into moles. There we go. I literally just wrote that on my hand. That's the sacrifice I make for you. Right, 10 grams of CaC2. So the first thing you do is you work out how many moles you've got. I'm going off the page. 10 grams. So that's calcium is 40. Let's have a little look. Get my calculator out, check this out. Now that might be too dark. Let's get it out of the shadow. Whoa! Right, calcium carbonate. So we're going to divide by MR, because that's what we know how to do. The MR of that is 40 plus 12 plus 12. I can do that. Come on, Norton. 64. Yes, divide by 64. Just checking in my head now. I thought it was 12. Was that 64? So I'm going to do 10. Can you see that on yours? Good. Divided by 64 equals 5 over 32. 0.15625. 0.15625. And that's moles of CaC2. So you're not, remember, I've not practiced these before. This is me just doing it for the first time. Okay, so that's not me doing like some sort of psychology on you. I have not seen this before, so I'm just working my way through. I'm imagining, you see, if I know the moles of that, it'll take me to the moles of this. That's a 1-to-1 ratio. Then I'll know moles of this, 0.15625 moles of ethine. Whoa, nearly knocked it all over. Are produced. So then I can times this by MR. 12, 24, 25. Can't read my own writing. 26 times by 26. That's still sitting on my calculator, that number. I haven't changed it. Times 26. 4.06 grams. 4.0625 grams. I didn't need to do that, did I? Because they didn't ask me for that part. Oh, yeah. Didn't need that. Anyway, they can have it. I won't get a mark for it. What I was after was this. This is the mole, so this is N. Didn't need to do that last step. So I've now got N, 0.15625. Let's really think this through. They gave me a mass of this, so I could work out the moles of this. I then worked out how many moles that will produce. So I know that I'm going to make this many moles of gas. This many moles of gas at 100 kilopascals and this temperature will occupy a certain volume. So we're going to do PV equals nRT. I want to work out V equals nRT divided by P. As long as you don't fall for the tricks of the units, you should be fine. 100 kilopascals is 100 times 10 to the 3, so 100,000 pascals. Easy. You're not going to catch me out. 20 degrees C, you need to plus 273. That's 293 Kelvin. I know, it's impressive maths there from me. Didn't even need a calculator. So all you've got to do now is put 0.15625 times 8.31 times 293 all divided by 100,000 and it'll spit out the volume for you. That's pretty straightforward. Now I'm going to skip past question 8 and have a little look. Well, I'll have a little look at it. What mass of potassium chlorate? 5. So that must be this. You don't know what that little 5 means yet, but it is a Roman numeral 5. What mass of potassium chlorate 5 must be heated to give 1 decimeter cubed of oxygen at? Okay, so it's a little bit of a, I will do this one, I'll do question 8. 2KClO3 solid arrow. So if you should only be looking now at this video if you've attempted these questions yourself. I suppose I should put that out there. I'm also looking at my phone. I've only got 11 minutes left of video space on my phone. Right, what mass of potassium chlorate? So I'm after a mass of that in grams. I'll try not to make the same mistake last time. Is heated to give. So that's a volume. There's a V, 1 decimeter cubed of oxygen at 20 degrees. Okay, I'm going to change it straight away. That's 293 Kelvin. At 0.1 megapascals. So that's 0.1 times 10 to the 6 pascals. Right. So with a volume, a temperature, and a pressure, they're giving me a volume, they're giving me a temperature, they're giving me a pressure. I don't know N, but I do know R. Right, there's enough information in the question to work out N. I hope you agree that, because they're giving me a volume, a temperature and pressure. Just need to watch the units. R is always 8.31. So you could work out moles of oxygen, which is this. You can work that out using PV-nRT. So you're going to get that. Then you can go backwards across here. 3 of these makes 2 of these, so a 3-to-2 ratio. That'll give you the moles of this, and then you can convert into a mass by timesing by the MR. That's your approach for that question. All right? Not seen that question. Well, I say never seen it before. I saw it last year, but that's how you would approach that. Look at the way I'm doing this. I'm seeing what it's giving me, and therefore I'm making my plan up as I go. I don't see these questions and go, oh, it's obvious what I'm going to do. All right? I'm working it out as I go. Question 9 then. What volume of hydrogen gas measured at? Right, okay, I'm going to start off by writing the equation. 2Na, that wasn't very good, plus 2H2O makes 2NaOH plus H2. What volume of hydrogen gas? They want that a volume, probably in meters cubed. Measure that. 298 Kelvin and 100 kilopascals. Right, hang on. Let me just collect my terms then. P, V, N, R, T. They're giving me 298 Kelvin. Units are fine. They're giving me 100 kilopascals. I'm going to turn it straight away because I'm getting used to it. That's 100,000 pascals. Boom, boom. It's produced when 1 gram of sodium. So they're asking me for a volume. They're giving me a P, a V. R is always 8.31. So I've got 2 unknowns. So I've got 2 things to know, so I need to work out something else. They want in a volume. Right, what else did they give me? 1 gram of sodium. They're giving me that information. See, I'm just turning the question into my advantage. I'm putting it where I want it. 1.00 grams, that's just reminding me 3 sig figs. 3 sig figs of sodium is reacted with excess water. That just means don't worry about the amount of water. Right, again, it looks steady. 1 gram, moles. Across to there, 2 of these makes 1 of these. 2 of these to 1 of these. Moles. So moles there, moles there. Then you've got N, haven't you? This would be moles, N. That goes there. Then you've got P, N, R, T. You can work out V. You might have to rewind the video and do that. But look, they're all the same. I'd write it out. Write down what information you've got. You've got reacting masses. Oh, these look very straightforward. Oh, if only you were all as clever as me. Now, the reality of that is a lot of you will end up being cleverer than me. Remember, I'm only a teacher. Ha! You know, those who can do, etc. So you just keep going. You'll be able to do these. You've just got to have the same approach as me. This is all about the mentality of, there must be an easy question under here. What volume of carbon dioxide? So firstly, look at this. Every single time, write out the equation. 1 of these reacts with 5 of these. 1 mole of this, 5 moles of this makes 3 moles of this. Plus 4 moles of this, 4H2O. What volume of carbon dioxide gas? So they want a V of that. Measure that. Okay, let me just connect terms. P, V, N, R, T. They want you to work out that. What volume of carbon dioxide gas, which is here. Measure the 800 Kelvin. I'm happy with that unit. 100 kilopascals. They like that one a lot. I'm happy with that. Forming 1 kilogram of propane. You're not catching me out, mate, with your kilograms. It's all about units, this one. Propane, prop means 3, so this is this. That's 1,000 grams is burned in a good supply of oxygen. Again, that just means enough oxygen. So what volume of carbon dioxide gas? 8.31, I'm going to write that in there. So again, look, I need to work out moles, then I can work out volume. Down there, moles, across, 1 to 3, 1 to 3. Don't need that bit. That's your N. Put your N in there, you can work out the V. Right, the person who asked me to go through these, are you getting the idea now? Okay, if you just said yes to your video, that's weird. Because I can't actually hear you. Right then, calculate the relative molecular mass of a gas which has a density. Right then, I'm just going to walk now. I'm going to do this in one shot, so I'm going to walk and talk, so I might go quiet. I've got to get some more paper. If I can open my printer. Yes. Right. More paper. So you might want to pause the video, go back over those questions, and hopefully realise PV equals nRT are easy. It's not a challenge, it's just watch for your units and know how to rearrange. If you don't know how to rearrange an equation, well, frankly, you shouldn't be doing A-level chemistry, so that shouldn't be the problem. Calculate the relative molecular mass, that's the MR, of a gas which has a density. Now, density freaks people out, so let me just try and talk to you a little bit about density. I've only got 5 minutes left on the video before it stops. Grams per decimeter cubed. You have a gas that has a density of this many grams per decimeter cubed. Now what that means, let's look at the units. It means that if you've got grams per decimeter cubed, if you have a decimeter cubed, which is another word for a litre, a decimeter cubed is 10 centimetres by 10 centimetres by 10 centimetres. It is telling you that that decimeter cubed of gas, that 1 decimeter cubed, weighs 2.615 grams. There are 2.615 grams per decimeter cubed. So I want you to imagine that. If you're holding a litre of gas in your hands, I know it's impossible, but just imagine it. It would weigh 2.615 grams. That's its density. That's all that means. If you've got a litre, it weighs this. If you've got 2 litres, it would weigh 5.230. If you've got 10 litres, it would weigh 26 grams. You got the idea? It's not that hard. So anyway, it wants me to work out the relative molecular mass. Well, I don't know how to do that yet, but it can't be that hard. They're giving me a temperature, they're giving me a pressure. So let's just see what we've got. P, V, N, R, T. Honestly, I don't know what I'm doing yet. 101 kilopascals, that's 101,000 pascals. Okay, I'm happy with that. 298 Kelvin, I'm happy with that. R is 8.31. Calculate the relative molecular mass of a gas which has a density of this many grams per decimeter cubed. So, let's have a little look. Oh, interesting. Right, I'm pausing now because calculate the relative molecular mass of a gas. I'm a little bit stuck because I've got an N and a V. So, of a gas which has a density of this many grams per decimeter cubed. See, this is where I get a bit stuck with my approach here of just trying to blag it. This many grams per decimeter cubed. How many decimeter cubes have I got? I don't know. Oh yeah, that's what I can do. Well, if I just say I've got 1 decimeter cubed, I'll just go with 1 decimeter cubed. So that would be 1 times, I don't know if this is the right way, by the way. That's 1 times 10 to the 3 meters cubed. I can work out how many moles are in that. Then I'll work out how many moles there are per decimeter cubed. I'll see how this goes. I had to come up with a volume, so I've come up with a volume. I know you might not have thought that. God, that was a bit of a delay, wasn't it? I've got 2 minutes 57 seconds. That's 3 minutes left. Okay, I'm going to see where this goes. P V equals N R T. But you know, I didn't go. Oh, I've seen this question before. I forgot. I don't know what I'm doing. Right, NRT. So I need N equals PV over RT. So I've chosen a volume, and I just chose one. P is 101,000 times V, 1 times 10 to the 3, that's 1,000, equals, that's PV, divided by, brackets, 8.31 times 298, close brackets, equals, number of moles. That doesn't look very good. 8.31. You know, what a wally. No, I'm not a wally. I'm doing all right. Keep going, Norton. Moles equals 40,785. That doesn't look right. In a litre of gas. No. No. I've only got 1 minute left. P times V. 1 decimeter cubed. You fool, boy. You fool. 1 times 10 to the minus 3. A decimeter cubed, 1 times 10 to the minus 3. I'm going to run out of time. No, I'm not. Right, I can do this. This is shambles, isn't it? Right, P times V. I noticed that was too big. That's a lot of moles. 101,000 times V. 1 times 10 to the minus 3. 1 times 10 to the minus 3 equals, divided by, brackets, 8.31 times 298. I haven't got a lot of time left. Equals 0.0407, that's better, 0.0408 moles. So I've got 0.0408 moles of gas. Here we go. Right, I'm done. I've now got this many moles of gas are in a litre. And I know the mass of gas that's in a litre. See, I'll get there in the end. So I now know my final little equation. MR, mass, Mr. moles. If I want to work out the MR, it's mass divided by the moles. Have I got time? I've got 27 seconds. Mass divided by moles. 2.615 divided by 0.0408 equals, please be a good number, 64. And I got 64.09. That's the MR. Right. Whew. Got there in the end. Learning point. Don't just accept the answer that it kicks out. I've got 10 seconds left. I haven't checked this answer. If it's wrong, I might be making a second video. Goodbye. Hope all is well. Try question 12 and 13.